Hello everybody, welcome to the CB&Q and the C&W in Wyoming. I'm Mark Pruitt. In this video, I'll show you how I repowered and added DCC with sound to an LM Blum brass model of a CB&Q Class S2 Pacific steam locomotive. The operating session I hosted in late June last year showed that I had a dire shortage of both motive power and rolling stock. We ran every engine on the layout and nearly every piece of rolling stock was moved as well. The rolling stock shortage was relatively easy to address. I just needed to build more kits. I did that. I added 40 more cars to the layout during the last half of 2023, and I still have well over 100 more kits yet to assemble. Addressing the motive power shortage would not be so easy. One thing I could do right away was press one of my Northern Pacific Mallee locos into freight service. This locomotive is really far too big for the layout. It won't fit on any of the turntables. But as a stand-in for run-through power, going from east staging to west staging and back, it would serve for the time being. But that was just a stopgap measure. I needed locomotives suited to the layout, preferably representative of the ones that actually ran through the area I model. I began watching eBay and a couple of brass train sites for likely candidates. In early September, I hit pay dirt. BrassTrains.com had a Burlington S2 Pacific for sale at a very reasonable price. The only problem was the motor ran, but the loco didn't move. I figured I could fix that, so on September 6th, I bought the loco. A few days later, it arrived. I took it out of the packaging and tested it using an MRC power pack. Sure enough, the motor turned, but the loco didn't move. I took this photo of the engine sitting in front of my BLI Pacific. It stayed there for almost 6 weeks. In fact, I didn't move it until I was cleaning the layout for the October operating session when I moved it over by the Grable turntable. Meanwhile, I ordered a TCS WOW 101-KA-Steam sound decoder for the locomotive. I also bought a high bass speaker and the various connectors I'd need to complete the installation. I did other work on the layout while I let the loco sit. To be honest, I was putting off working on it because I was more than a little intimidated by the task of getting it operational. I'd never worked much on brass locomotives before, let alone converted one to DCC. But after the October operating session was over, I had no more excuses. It was high time I got started. The first order of business was to figure out why the motor didn't turn the wheels. I flipped the loco over and put it in the cradle. I took photos every time I removed a screw or a spring, or did anything else for that matter. I wanted to be able to reassemble the thing someday. When I got the superstructure off the chassis, the reason the loco didn't move revealed itself. The plastic coupling between the motor and worm shafts was broken. Shades of cracked gear problems. I was actually relieved to see this. I knew exactly how to fix it. Then I looked closer at the worm assembly. Unless I addressed the huge amount of axial play in the worm, the thing would never run well. So I removed the worm assembly. Like before, I took photo after photo as I disassembled the model. What you're seeing is not nearly all the photos I took. Finally, I had the worm assembly out of the mechanism. I disassembled that and took a variety of measurements to determine what size and how many washers I would need to correct the excessive lash in the worm. I found some suitable brass washers on eBay and placed an order. I set the locomotive aside again while awaiting their arrival. While I was figuring out how to fix the worm assembly, I also looked into what motor to use to repower the locomotive. That open frame LMB motor just wasn't going to cut it. After consulting the Repower and Repair I/O group, I ordered these Mabuchi motors off eBay. The washers arrived in mid-November, and I had an easy time installing them in the worm assembly. It took 3 of them to reduce the axial play to a reasonable level. The motor arrived about the same time as the washers. After I reinstalled the worm assembly into the locomotive chassis, I installed the new motor. I used neoprene tubing for the new connection between the worm and motor shafts, positioning the motor on the frame to provide just a very small space between the ends of the shafts. I attached the new motor to the frame using adhesive caulk, the same stuff I used to attach track to roadbed, being careful to position and angle the motor to make sure its shaft was in close alignment both axially and laterally with the worm shaft. The next step, after the caulk holding the motor in place was fully cured, was adjustment, lubrication, and testing of the entire drive mechanism. I took my time doing this, as a poorly running locomotive would not be acceptable. I adjusted the position and angle of the cylinders casting, very carefully straightened some slight bends in the crosshead guides, and adjusted them so they were actually parallel to each other on both sides, and also did some minor straightening of the various side rods, main rods, and valve gear rods. Then I lubricated all rotating and sliding parts using tiny amounts of Labelle 108 oil. To do that, I picked up a tiny amount of oil off the bottle applicator with the tip of a number 5 X-Acto blade and slipped the blade in between the moving parts. I also added a couple dabs of Labelle 106 grease to the worm. By the time I was done, I had a smoothly operating mechanism. I tested it by applying power to the motor with an MRC Rail Power 2 power pack. Very early in December, part 1 of the project was done. I had what seemed to be a mechanically sound, smoothly operating chassis. Part 2 was installing the decoder and finishing up the locomotive. That would wait until the new year. Installing the decoder, keep alive, and speaker meant, of course, tearing into the tender. Like with the locomotive, I took plenty of photos as I did the initial disassembly. I got started on January 4th. By the way, I wound up not reusing that tender weight. It's in a bag with the old motor, probably to sit gathering dust for years to come. First order of business was to decide where to attach the connector that mated the locomotive to the tender. Looking closely at the tender front, the location seemed obvious, just below the tender deck. For no particular reason, I chose slightly right of center. Working as carefully as possible, I drilled a small hole in the bulkhead under the deck, stepped up through several intermediate sizes to the final size, which I determined from the width of the connector. Then I cut the sides of the hole out to the bottom of the shell. This photo shows what it looked like after I cleaned up the edges a bit with a file. This was the connector I selected, the TCS 6-pin mini connector. I would need to use 5 of the pins, 2 for the motor, 2 for the headlight, and 1 for power pickup from one of the rails. The tender would provide pickup from the other rail. My plan was to attach the female side of the connector flush with the front of the tender bottom deck, which meant the wires would be passing through the hole in the shell. To make sure the edges of the hole in the metal shell didn't abrade the insulation over time, I brushed a small amount of liquid electrical tape around the edges of the hole to act as a grommet. The next morning, I made modifications to the base of the tender for the speaker. First, I marked the speaker's position, then set to work drilling the holes to let the sound out. That looked like it was going to be a long process. The first hole took about 20 minutes to drill. Like the hole for the connector wires in the shell, I started with a very small bit and stepped up through several sizes to the final size. If I had to drill all the remaining holes that same way, I'd still be working on it. Plus, I'd have gone through who knows how many bits to finish. I needed a better way. And I found it. I had a few small ball cutters in my stock of Dremel accessories, and I thought the smallest of these might do the trick. The brass tender floor isn't overly hard, so the cutter might work better than those tiny drill bits. It sure did. I went from about 20 minutes a hole with the drill bits to about 20 seconds a hole with the ball cutter. 15 minutes of work finished the entire task. The final step for the holes was to deburr them using a small pointed stone grinding bit. The end result wasn't pretty, but it works just fine. The final hole size is roughly a 1/16 of an inch. I wound up choosing that simply because that's the diameter of the ball cutter, and that size hole looked about right. The next size cutter I have is 3/16 of an inch, and that would have been too large. Then I touched up the paint on the shell where I drilled the connector hole. The paint sheen isn't a good match, but that spot's very hard to see, so it isn't important anyway. I didn't touch up paint around the speaker holes. That area is completely invisible when the loco is on the tracks, so why waste the time? Next step was to glue the female side of the connector to the tender base. I did this using plain old thin CA. I had no idea how well that would hold, but after connecting and unconnecting the loco several times, the bond seems very solid. With all the preliminaries out of the way, I began doing the actual wiring. This was my general approach throughout: solder the wires from the connectors to the appropriate wires on the locomotive or decoder harness, then use heat shrink tubing to insulate each joint. First, I did the loco. In this shot, I've attached the black wire to the loco frame for power pickup and the blue and white wires to the headlight wires. Motor connections, the orange and gray wires, would wait. The red wire is unused, and I clipped it off near the connector. That was all easy enough, but as you'll see later, I had to come back and redo all the connections in the loco. Then I moved on to the tender. It's still the 5th of January, by the way. Here's the first connection between the decoder harness and the tender to loco connector. This is one of the headlight wires. Through this entire process, I used the TCS wiring diagram. This is a bit confusing because the position of the wires in the harnesses don't match the positions shown on the diagram. A note on the diagram tells the installer to wire to the colors rather than the diagram position, so that's what I did. The connector wire colors matched the decoder harness colors, so that made the entire job easy. The morning of the 6th was a big day in this project. It was time to test the electronics. I clipped alligator leads between the motor wires and the motor terminals because I didn't know which wire went to which terminal. If I got them reversed, the locomotive would move backwards when the throttle indicated it should be going forwards. That's easy enough to correct when programming the decoder, but I figured I should just get it right now. Sorry for this rather fuzzy video clip. While the color coding made the wiring almost idiot-proof, I figured I'd be the idiot to get it wrong if anybody did, so I would not have been surprised to see the magic smoke come out of the decoder when I applied power. To my utter amazement, when I turned up the throttle, the locomotive actually moved. I was almost in shock. While I still had to wire the speaker and attach the keep alive, a truly idiot-proof task, I considered the first power-on test to be a complete success. I noted which motor wires went to which motor terminal and later soldered them in place. With the test complete, I did some prep work on the second harness, the one with the keep alive and speaker connections on it. There are several other wires on this harness that I wouldn't be using for additional lighting and a cam to synchronize the chuffing of the locomotive to the driver rotation. I cut these wires short and dipped the tips in liquid electrical tape to protect them from shorting. On the 7th, after the liquid tape dried overnight, I attached the speaker to the second decoder harness and plugged it into the decoder. I stuck a square of double-faced foam tape to the underside of the tender upper deck to mount the decoder and keep alive. After this photo was taken, I used dabs of low-temperature hot glue to position and support the speaker, pressed the decoder and keep alive into the double-faced tape, and reassembled the tender. It was a bit of a job to stuff all the wires into the tender without crimping and possibly damaging one of them, but after about 15 minutes of carefully moving wires around to clear the shell mounting brackets, I got it all back together. I did a quick test to make sure everything still worked, then turned my attention to reassembling the locomotive. The locomotive was more difficult than assembling the tender had been, but by referencing a lot of those photos I'd taken during disassembly, I got it done. Still, that pilot truck looks mighty close to that first set of drivers, doesn't it? I put the reassembled locomotive on the tracks and tested it. I was both pleased and dismayed at the same time. The locomotive seemed to move smoothly and the sound worked, but the loco shorted across the rails on one of the switches, and that headlight was dazzlingly bright. Other than being white, the incandescent headlight looked like the bulbous nose on Bozo the Clown, and it flickered a lot as the loco moved. I was able to address the short very easily. Remember how close the pilot truck was to the first driver set? The pilot truck frame isn't quite symmetrical around its pivot point. Someone, either at the factory or later, had assembled or reassembled the pilot truck backwards. I know it wasn't me because I hadn't disassembled it. So I did take it apart and reversed the pilot plate on the bottom. You can see that the rear set of pilot wheels now easily clears the front drivers. That eliminated the shorting problem. I ran the loco around the layout a bit over a period of several days to see how it performed. I came up with 3 modifications I thought would improve the model. First, I needed to improve the tender power pickup. The headlight flickered badly as the loco moved along the line. The keep alive kept the loco moving, but clearly pickup was a problem. Number 2, I needed to do some wire management in the cab. All the wires in the locomotive were too long, and they wound up wadded together and very visible through the cab windows. And third, the headlight was extremely bright, to say nothing of being very bulbous. It protruded far enough out of the housing that you could see it shining brightly even from the sides. I started with the tender power pickup. This view of the disassembled bottom of the tender shows that the tender relied primarily on the contact faces between the brass truck bolsters and the bosses on the tender bottom. The retaining springs and steel screws that hold the trucks in place also might carry current, but even together this arrangement did not provide good solid pickup. I ordered some 1-72 and 080 screws, plus the associated hole taps and drills from McMaster Carr. Then I left the loco alone again until the hardware arrived. The parts showed up on January 24th, and I immediately began fabricating electrical pickups. I didn't take many photos from this point onwards, I'm afraid. Sorry. First, I fabricated a wheel wiper using some phosphor bronze wire my friend Dave gave me. Then I drilled and tapped 1 truck bolster for a 1-72 screw. The wheel wiper put too much drag on the wheels, so I reshaped it to drag on the axles, which you can see here. Finally, I drilled and tapped the opposite side of the bolster for another 1-72 screw. This would allow for connection of a small wire to carry power from the truck right to the tender body. Here's the new power pickup truck fully installed. You can see where I drilled and tapped, then installed a screw into the bottom of the tender, to which I connected the other end of the wire from the truck. The only bit of hardware I forgot to buy, you didn't think I wouldn't forget something, did you? Was the washers for the 1-72 screws. Fortunately, the brass washers I purchased for adjusting the worm lash fit. They're number 2 washers, so they're a bit bigger than they need to be, but they do the job. The one on the truck bolster barely clears the tender mounting boss, so I may order some proper size number 1 washers and replace these. Then I addressed the headlight and the wad of wires in the cab. As you can see, even in this blurry photo, those wires were a mess. They had to be tamed. And this photo of the loco pulling a train through the Wind River Canyon shows just how bad that headlight really was. It actually hurt a bit to look right at it. The idea was to shorten most of the wires in the loco so that there was little slack between the loco and the connector when the connector was plugged into the tender. At the same time, I wanted to be able to completely remove the boiler from the chassis if the need should arrive, without it being tethered closely to the chassis by the headlight wires. To allow for removal of the boiler, I added this TCS 2-pin connector to the headlight wires. Fortunately, I had a couple of them on hand, so I didn't have to wait for an order to arrive. I planned on addressing the too bright headlight by putting a resistor in series with it, but even 1-watt resistors got hot. That headlight was pulling a lot of power. I got concerned that it might overtax and burn out the decoder in short order, and besides, just adding a resistor wouldn't address the ludicrous appearance of the light from the side, so I went on to plan B, replace the bulb with an LED. I wasn't at all sure I had a suitable LED. I figured I would need to order one. Another delay. But as I looked through my LED bins, I found I had the perfect thing. Some time ago in the dark and hazy past, I bought a pack of warm white LEDs from Evan Designs. These things have inline resistors and rectifiers, so they're ready to install for a wide range of voltages. The decoder I used outputs 12 volts on the lighting lines, so these should work perfectly. I tested them by alligator clipping one to the disconnected headlight wires on the local connector. It worked great, but it, like the incandescent bulb, was too bright. There was another problem with the LEDs also. That was the inline electronics. The LED was a bit too big to push through the headlight housing from the back, so for sure the blob that was the electronics wouldn't go through the other direction. Both problems were easily overcome. I could put a resistor inline downstream of the electronics to reduce the brightness of the LED a bit, and it would be easy enough to simply clip and then reattach the other wire while I was installing the resistor. So I clipped one of the LED leads and did some experimentation with resistances in line to arrive at the correct value for my needs. I think it was 330 ohms, but to be honest, I don't remember for sure. Anyway, it worked great. In this photo, you can see where the first lead was cut for testing and installation of the resistor, and I marked the other wire with a white paint pen since polarity would matter downstream of the electronics. Not many photos taken here either, so we'll have to keep staring at this one. I installed the LED and soldered everything in place and turned on power to test the new headlight. Nothing. Somewhere during that whole process, I ruined the LED. So I repeated it with a second LED, and this time it worked when it was all done. I also shortened the wires to the motor and the frame, and lassoed all 5 wires with a short bit of heat shrink tubing. The new headlight looks much better, and the wires, while still visible, are much less obtrusive than they were before. I'll spend a bit more time at some point with tweezers and a wooden skewer to push and pull the wires into more obscure positions. After running the now completed locomotive and passenger train around the layout a bit more, it turns out there's one more issue to address. The lead weight in the boiler extends from the smoke box back to a point just over the first driver set. The locomotive is poorly balanced, and tractive effort suffers as a result. The engine can pull an express box car and 5 passenger cars around the main line just fine, but it will not be able to climb the grade out of staging even with just 4 passenger cars. There are 2 possible solutions: add bullfrog's knot to one set of drivers, or add additional weight to the boiler in the dead space above the worm and drive shaft over the second and third sets of drivers. Doing the first may impact the electrical pickup of the locomotive, which only gets power, I think, from the 3 drivers, so I'm leaning toward the second option. I can pour a low melting point ferro-alloy metal into the boiler, and it can easily be machined away to clear the worm and drive mechanism. I did this years ago on another locomotive, and it worked like a charm. Ferro-alloys generally have a melting point lower than that of boiling water, and they're non-toxic to work with. But I'll wait a while before I go that route, and I may try the bullfrog's knot first anyway. If it does impact electrical pickup, it can be easily removed from the drivers. we come to the end of this project. Aside from addressing the traction issue, which will be easy regardless of which option I choose, the locomotive conversion is complete. All told, I probably spent well over 50 hours remotoring and adding DCC to the engine, but most of that time was fun, and the final result is immensely satisfying. This first conversion has given me the confidence to tackle the next conversion, an R1 Prairie locomotive from Nickel Plate Products. It's much smaller than the S2, including the tender, so adding the decoder and keep alive will be a bit more of a challenge, but I think I can do it. That will happen in a few months. I also have two brass Great Northern locomotives to convert to DCC and possibly repower, an H6 Pacific, and my favorite locomotive of all time, a P2 Mountain. While not strictly at home on my CB&Q mainline, I can justify the appearance of these GN locos as World War II emergency equipment loans. In closing, I want to thank the members of both the Repower and Regear and the TCS Users I/O groups for their assistance in answering my often simplistic questions and otherwise providing encouragement and support. Their wisdom was critical in completing this project. Thanks for watching, everyone. Until next time, stay safe, stay healthy, and happy model railroading. See you soon.